This is the first in a series of videos on a titration of a weak acid by a strong base. I broke them up into several different videos so that none of the videos were too long. And so in all of these videos, we'll be considering the titration of 100 milliliters of 0.8 molar nitrous acid with 0.5 molar sodium hydroxide. And in this first video, we want to know what is the pH before any base is added. And so if no base is added, all I have is 100 milliliters of 0.8 molar nitrous acid. And so all this problem is really asking is, what is the pH of this weak acid? And so this is just an equilibrium problem that we have done before. So if I want to know the pH of a weak acid, I need to write the equation for the dissociation of that acid. And so I have HNO2 will react with water, and it will be in equilibrium with H3O plus and the conjugate base. All right, so this is an ice table. So the initial concentration of the nitrous acid is 0.8. I don't care about the water. The H3O plus and the conjugate base both start out at 0. So my change is going to be minus X and plus X for the products. All right, so I need to now plug this into the equilibrium constant expression. So we know that Ka is equal to the concentration of H3O plus and the conjugate base over the weak acid. So I can go ahead and plug in my values. I know that I have 4.6 times 10 to the minus 4 is my Ka, and I'll have x squared over 0.8 minus x. Now, as usual, when we have these calculations for the weak acids and weak bases, we can apply the K is small approximation, so we can ignore the minus x. And so my problem becomes all right, so I multiply both sides by 0.8. So I get 3.68 times 10 to the minus 4 is equal to x squared. Take the square root of both sides. So I get that x is 0.0192 molar. And we should check that the K is small approximation is good. And when I did that check, I got around that the x was about 2% of 0.8. And so the K is small approximation is good. And so this x is the concentration of H3O plus. So to get the pH, I just need to take the negative log of it. And so the pH is 1.72. All right, and in the next videos, we'll look and see what happens to the pH when I add sodium hydroxide to this weak acid.